Welcome to this tutorial of Alva's software suite called TorqStudio. This is presented by me, Anton Franzén. I'm the Director of Product Management and Application Engineering here at Alva. So TorqStudio is a software suite that allows you to both create your own motor designs, analyze those motor designs, and also perform analysis of our standard motors. So I'm going to be showing you the basic functionalities we have in this software suite, and just going to go into some of the details, what you can do and so on. So let's start with the first functionality we have here called Create Motors. So we'll go in here. So what this module will do is to allow you to make your own motor designs. So what you have to feed it with is the high-level requirements. So we only have to give it the outer diameter and the actual length that you want of your frameless motor. So let's say we want to do a 80 millimeter long, 80 millimeter big motor in outer diameter. And let's say that it's supposed to be 30 millimeter long. Then we click optimize here. What it does is it takes these two high-level requirements and makes thousands of motor designs. And then it selects the one that is the best. And when I say the best, it's the best in terms of motor constant versus motor mass. And these motor designs are created with analytical models that is fully developed by Alva. So these models are very fast. We don't have to run any finite modeling in the background. It's just analytical models running. So they're very fast. So what you can see here in the graph is that we have motor constant on the y-axis and we have motor mass on the x-axis. So it creates this wavefront with the best motors that it was able to produce and present it to us. It will create somewhere around 100 to 150 motor designs that we can select from. In this case, it created 128 designs for us. So what we can do now is basically just select the motor that we are most interested in. And I know in my case, I don't want to have a motor weighing more than 300 grams. So I'm going to select the motor here that is just at my mass target. And then when I've selected the motor here, it'll present me with the motor specification of that. So I can see, okay, the outer diameter ended up at 80 millimeters as we desired. The actual length is 30 millimeters, also as we desired. And then I can see the torque constant, I can see the resistance, I can see the motor constant, the mass, all of this. So if I feel that I'm happy with this motor, I can save this design, which allow us to later on analyze it, give it some operation points and see how hot is it gonna run, how efficient will it run. So I'll name it 8030. Let's do V1 so we recognize it. So I save it here. You don't have to select which stator configuration you want because all of them will be saved. So when you later on go and analyze it, you can select what's most suitable for your application. So let's jump back to the main page. So we can go and click Analyze Motors, which will allow us to analyze this motor now. So we'll click here. It will show you this interface. You can select a design. Here we find two motors. The one I just created is the 8030 motor. So I click that. And here, as I said, you can select the stator configuration you want. So let's do a 8Y. I'm working with a gimbal application. I want something that has a really high torque constant. I don't really need high speed. So then the 8Y is very suitable. So I select that. Here I can select if I want to add some resistance or inductance between the driver and the motor. In this case, there's no need for me. Here I can enter the supply voltage I'll be running 28 volts in this case. My ambient temperature is 20 degrees. That's all fine. Here I can select the cooling preset. So I can either go with the cooling presets that we have, or I say that the motor is going to have a certain temperature all along. But let's run with a cooling preset, let's say mid. If you want to see the definitions, we have the definitions included here. So you can see what fits you best for your application. If that's low, mid, high, you select that. Then I feed it some operation points. So say that I want to run 0.75 Newton meters. I'm going to run quite slowly. It's a gimbal application. I apply the supply, the driver switching frequency here. I add another operation point. I want to be able to run 1 Newton meters. Let's say that that's a slower speed. We'll have the same switching frequency. So I fill that out. You can add as many operation points as you desire. You can create this matrix in Excel and then just copy it, paste it in here, and you can run those operation points. And then I click calculate. Then it will take these operation points that we've given it, run through them, and give us the result. So as I said before, all of these models are developed by us at Alva. The whole software stack is done by us, so we have full control of what happens. Here we go. It gave us, first of all, a speed torque curve. So you can see the red one is when the motor is hot, and the blue one is when the motor is cold. And what this graph means is that as long as you're within these two lines, those operations point can be done with this voltage, basically. This supply voltage allows us to run within all of this area. And then you also have these lines. This is the continuous torque. This is the peak torque for 10 seconds, 5 seconds, 3 seconds, and 1 second. And you also see the two operation points we gave it. So we see that it's well within the capability of this motor. Then we can also see the exact output data for these operation points. So we can see the mechanical power. We can see the duty cycle that's required to reach this operation point. We see the currents, see the electrical power, motor efficiency, stator temperature, rotor temperature. So you can run all the operation points and make sure you get the efficiency you need, make sure that the motor handles that firmly. And then what you see down here is the current. So this is the actual current waveform that the motor sees. And you can also see the fundamental current, the ripple current, total current, and peak current. This allows you to select the correct motor driver for the specific motor. And we can also see the second operation point. So you can check all the operation points that you require. And then if you feel that, this looks good, I want to have all this data locally, you can click download here. You name it and you click OK, and you will get an Excel report with all of this data, both the motor specifications, your operation points, and the output result of that motor. Good. And then we can go back and have a look on the last functionality. So that is design database. What you will see in the design database is all of your custom motor designs, but also all of Alva's standard motors. And then you can go in and click here, and you'll see all the specifications of these motors. There's a very easy way to check out the specifications of your own designs, but also Alva's designs. And if you feel like, this motor actually would suit my needs, you can click request quote here, fill out some information, and then click send. And this request will go directly to our sales team, and they will reach out to you. You can do this both with our standard motors, but you can also do it with your own motor designs if you're interested in a custom solution. So try that out. Let us know if you're interested in anything here. So yeah, that's the full functionality of TorqStudio. Try it out and let us know if you have any feedback or you need any support with using it. Thank you for listening in.